An electron in a hydrogen atom in its ground state absorbs, it should be there, in the ground state, absorbs 1.50 times as much energy as the minimum required for its escape, that is 13.6 electron volt from the atom. Calculate the wavelength of emitted radiation. So students, we have done such sort of question. Say how much energy is required. Say I have got an atom over here. Right, let's answer. Say this is an atom, right? Now, there is electron in the ground state. So for its escape means just for this electron to move out. How much energy is required? It is 13.6 electron volts, right? So 13.6 electron volts is required for the escape of electron. That means it is its ionization energy, right? Now, what is this electron doing? This hydrogen atom doing? Now, this atom is absorbing how much energy? 1.50 times. Times of what? Times of 13.6 electron volts. It means how much energy it is absorbing? It is 1.50 into 13.6, and this gives you what? What will be the thing? 1.50 into 13.6, and it will give you 20.4. It means your hydrogen atom is absorbing 20.4 electron volts of energy. Right? So, the new energy or the energy of the electron will become how much? Or your delta E, that will be how much? This would be minus 13.6, which was initially at the ground state, plus this has absorbed how much of energy? 20.4 electron volts. I think you are getting why I am adding this. What is the electron doing? The atom doing? It is absorbing this much amount of energy. So after absorption of this much amount of energy, that is 20.4, the electron will get excited to some other orbit, and there it is going to have some different energy. So first we will calculate the energy of electron in that orbit. So how much it will come? It is 20.4 minus 13.6, and we will get 6.8. So what is the energy of electron has become? It has become 6.8. Now students, we don't know where the electron has moved after absorbing this energy. Right? So let's find out this. It is energy is equal to minus 13.6 into z square upon n square. Right? So your En is how much? The energy has become 6.8 electron volts. So it would be 6.8 is equal to minus 13.6 and into z square, that is a 1 square upon n square. So your n square will be equal to 13.6 upon 6.8, and that would be 13.6 divided by 6.8, and that will give you 2, right? And the root of 2 would be, n will be the first energy level, right? Or students, we can do it despite finding out the number of energy level. What we can do is, we have got delta E here, right? So what is your delta E? Your delta E is 6.8. I'll just correct it. I'm actually going a bit lengthy. I don't want to tell you this lengthy procedure. Okay? So what we can do here is, I'll tell you. So what is the difference in the energy we are getting? The difference in the energy, that is delta E, is 6.8 electron volts, right? That is, this is the difference in the energies of the electron. Now what we require is, we require the wavelength. So despite going the lengthy way, just finding out the orbit and all those, we can just find it out by the formula which I gave you. Lambda is equal to h upon, what was it, square root of m into 2 into the kinetic energy, right? Now here your energy of the electron is 6.8. It is an electron volt, so convert it into joules. So what would be the thing? We'll just multiply it with 1.6 into 10 to the power minus 19 joule, so that our energy is, the energy now comes out to be 10.88 into 10 to the power minus 19 joule. Just multiply this. It is 6.8 into 1.6, that is 10.88. So students, we have got our kinetic energy here. Now put the values over here, that is lambda is equal to, what is the value of h? It is 6.626 into 10 to the power minus 34, and that has to be divided by square root of 2 into, what is the mass? Mass is 9.1 into 10 to the power minus 31 kg multiplied by the kinetic energy. Right? So from here you can get your wavelength. Just do the calculations, and the wavelength which you'll get from here is 4.71 into 10 to the power minus 10 meters. Got my point? Previously the procedure I was doing, it was very lengthy. So do it by this method. First find out the energy difference, convert that particular electron volts into joules, or forming the kinetic energy, and then take out the wavelength of the light emitted. I hope there is no confusion over here. I'll just do it again. It is an electron in a hydrogen atom in its ground state absorbs 1.50 times as much energy as minimum required for its escape from the atom. Calculate the wavelength of emitted electron. It means your atom is absorbing this much amount of energy, that is 1.50. So the energy of the electron is becoming 20.4 electron volts. So the difference between their energy is 6.8. Convert this energy and get the kinetic energy, and put the value in the wavelength equation. So that you are getting your wavelength. So what is the wavelength of the light emitted over here? It is 4.71 into 10 to the power minus 10 meters.